Here we are considering the market for cigarettes given by the following equations. The demand curve has a y-intercept of 50 and a slope of -8. In other words, the demand price is equal to 50 minus 8 times the quantity demanded. The supply curve has a y-intercept of 10 and a slope of +2. In other words, the supply price equals 10 plus 2 times the quantity supplied. Right? And then our equilibrium in the market for cigarettes will be where supply equals demand, Q star, P star. We can solve for those by setting supply equal to demand. So supply is 10 plus 2Q. And demand is 50 minus 8Q. So when we solve that out, we get Q star equals 4. So we'll label that in our graph here. And then we plug back that Q4, we plug it into either the demand curve here to solve for P star or the supply curve here to solve for P star. So let's go ahead and plug it into the supply curve. Either one will give you the same answer. And we get a supply price of $18. So each pack of cigarettes costs $18 and there are 4 of them bought and sold. All right, now the particular issue with the market for cigarettes is that cigarette smoking exhibits negative externalities, right? So negative externalities mean that there's some negative spillover effect onto people other than those directly consuming the product. So the smoker is smoking, but the secondhand smoke that she is creating could be negatively affecting the people around her by annoying them or even harming their health. So our private market, our free market here, does not internalize that negative externality. It only internalizes the private costs of making the cigarettes, so the private marginal cost, and the private marginal benefit for the consumer of the cigarettes. So when we solve for Q star, this Q star is equating the private marginal benefit and the private marginal cost to get us to an equilibrium. And normally that would be the efficient outcome, but it's not in this case because this negative externality is not taken into consideration. If it was, we could think of the true cost as being higher by the amount of the negative externality. So when we have higher cost, we shift in or up our supply curve by the amount of that increased cost. So if we shift our supply curve by the amount of the externality here, then we get a new supply curve that's equal to the private marginal cost plus the negative externality. Right, so first off, a quick note, we have to be able to put a monetary value on that externality so we know how much to shift up the supply curve for this thought experiment. And plenty of economists spend their time trying to put a monetary value on things that might be hard to quantify. So that's a whole area of rich research. All right, but assuming that we know that this externality is, let's say, worth $20 per pack of cigarettes, for instance, then we would shift up the supply curve by $20. And then we see if the market were to actually internalize this externality, the supply curve would be this green one, and the equilibrium would be at this intersection right here. So this right here would be the quantity, and I'm going to call this quantity O for optimal, right? And to see why this is the optimal quantity, consider all of the transactions that occur between QO and Q star. All right, so for each of these transactions, right up here in the graph, we see that the demand curve shows us the marginal benefit of each of these transactions between QO and Q star. And the green supply curve tells us the true marginal cost of each of those transactions. So we see here that the true marginal cost is greater than the marginal benefit. And we know that anytime cost is greater than benefit, that these transactions should not happen, right? It's irrational to take an action where the costs are greater than the benefits. Yet that's exactly what the market does. It takes us all the way to Q star, even though all these transactions between QO and Q star really should not be happening at all. And this is the market failure that we're seeing in the market for cigarettes, which exhibits a negative externality. At QO, if we could get the market to stop at QO, we see that the true marginal cost equals the marginal benefit. And that's where we would want to be to have our efficient outcome or optimal outcome where social welfare is being maximized. So now a question to consider is, how might government policy be used to correct this market failure? That is, to get Q star down towards this optimal quantity. That's our efficient allocation of resources, right? And so one option is to use taxation policy. So let's remind ourselves of what taxation looks like in a market, and we'll see that it actually looks really familiar or very similar to the previous graph we just saw. So recall in a market, just any old markets with supply and demand, okay, if that market is currently at equilibrium and then we impose a tax, well, remember there's a few different ways to impose a tax. So you could either shift the supply curve up to represent the tax as an increase in marginal costs, or you could shift the demand curve down to have the tax represent a diminished marginal benefit by the amount of the tax. So I'm going to go with method 1, where we shift up the supply curve by the amount of the tax, let's say $2. And so our new supply curve is just this original one plus the tax, right? And then we see that this act will then shrink the size of the market to QT, T being tax, right? And it does this by creating a distortion in the price. So consumers now pay a higher price, right, which will lower their quantity demanded from here to here. And at the same time, it lowers the price that producers get, thereby reducing quantity supplied from here down to here. So both demand and supply are reduced, and so we end up at QT. And just to remind ourselves, the gap between these two prices is equal to the tax. Sorry, having some technical difficulties there. So we see now pretty clearly how we could use a tax to correct the market failure in the market for cigarettes, right? If we can figure out the size of the externality, right, then we set the tax equal to that quantity. So if the externality is measured at $20 per pack of cigarettes, then we would tax cigarettes at $20. If we think that externality is only $5, we would tax the market at $5, right? And once we do that, then it shifts this curve up, and we end up here. And so the quantity of transactions decreases from Q star down towards the optimal level of transactions. We might consider some other policies to reduce the number of cigarettes being bought and sold. So one might think that maybe a price ceiling might do the trick. So let's consider that, or a price floor. we know that both of those will reduce the number of transactions in a market. And if that's our goal, well, then maybe that's a possible policy. So let's see what that looks like. All right, so let's say we put in a price floor. So a binding price floor will be above the equilibrium P star, right? We're not able, with a binding price floor, we cannot charge below, so we cannot get to P star. We can only charge something above, right? So the market will end up at P star, and with a higher price, then yes, we're going to have fewer consumers buying cigarettes. Quantity demanded will fall. However, we'll have more cigarettes being produced as quantity supplies increases, right? We'll have this disequilibrium where we have a surplus or an excess supply being produced. And while we have successfully reduced the number of transactions down closer towards the optimal quantity, right? And maybe we even really nailed it and got right to, if this is the optimal quantity, then maybe we achieved our goal. But the negative outcome here is that we've created this disequilibrium where we have a surplus of cigarettes being produced, and that hardly seems like the most efficient use of resources to be producing a product then that people aren't going to be buying. So I would argue that when comparing these two different policy options, price controls versus taxes, taxes are going to do the job sort of more efficiently because it'll avoid creating this disequilibrium of a surplus or a shortage in the case of a price ceiling. And taxes have the added benefit of also providing us with tax revenue that can be used to perhaps, educate people about the dangers of smoking.